So this is demo 4. I went down a bit of a rabbit hole, but hopefully it's worth it in that. So I have this layer. It was in QGIS. Might have technically been a GeoPackage layer in that. And so what I did is I exported out as JSON and also as Mapbox vector tiles in that. So there's a GeoJSON version of this over here and that. And it doesn't, so it's a feature collection. The name is Surrey. There's a CRS 3857. This will cause you problems in Leaflet if you don't add some more libraries because it likes things in lat long 4326. We have our features array and we have our first feature, fit ID 1, city center, right? The number of schools is 8. So these are the properties. And this is the geometry. It's multi-polygon and the coordinates. And the big thing to get a feel as a JS person is those are real world Webmaker coordinates. Those are in meters. That's in that particular projection. In that, again, I'll just keep hammering this. For smooth sailing in Leaflet, you would really want those to be lat longs and that. So GeoJSON has real world coordinates because it's a JS file and we have to overlay with other data, and sometimes that data is in different projections. So we need a real thing to project from a real coordinate system so we can do the math, get you landed in the right spot. Okay, so that's the life of GeoJSON and a lot of spatial formats in that. But will this come back? It's coming back slowly. Maybe I would say not happy all of a sudden. Let's see. Oh, so cranky, my GPU. It's happier now. So we took the GeoJSON just so we have something. Okay, that's what GeoJSON looks like. Now, there's a processing toolbox in QGIS. Now, I don't know if it got there after I added a plugin or if it was already there. Something I would have to check. So there's two options. You can export your layer as a Mapbox vector tiles, or you can export it as XYZ vector tiles in that. The thing with Mapbox vector tiles, the very first option, this one right here, is that it actually puts it in an SQLite database, right? And so that's okay, but it's in a table, and then you have to find the row, and there's a blob column, and inside that, what the columns are on that table are like basically the Z, X, and Y values, so that you can scan the table to find out what zoom level. Okay, it's these rows. Which X? Okay, these rows. Well, which Y? And that would isolate what rows in the table you need. And then you have to go over to the blob column and pull out the protocol buffer format. So the big thing about vector tiles is that it's stored in this binary version of JSON and that. And so what they do is they stuff that into a blob field in the table in the SQLite database. But for our purposes, that's harder to work with. There's another option to say same kind of thing, but instead of putting an SQLite container, just do it as directories and files on disk. So I picked that second option after that. The other one kind of like threw me off. That's okay, not what I want. But this hits home on this tiling scheme, right? So this is the tiles that I exported right here. I didn't get all 22. I probably don't have enough data, like it's just not enough and that sort of thing. But these would be my zoom levels, 0, 1, 2, 3. I'm probably at the bottom in terms of resolution at that point. But in there, right, now the way that VS Code shows this I'm not into, but it means you're in directory 0, 0. So that would be your X directory, the second 0. And there is a 0 like PDF file, and that's like the Y, right? And then down in 3, we have a 3.1 on that, and we have 2.pdf in that, and also have it converted to JSON, so we can take a look at it. Well, what does it really look like, and that sort of thing. So there's a few things I did because I'm in VS Code and I have Node. I might as well install the protocol buffer format package in that, and there's a little thing where we have to. I wonder where we have to convert this vector tile proto file basically into a JSON version. And so your question, well, why is that? So what it is the proto file says that binary data, this is how it's stored, right? The thing is, they don't know if you're going to be in C, C++, C Sharp. They know Python. They don't know what language you're going to be in. So it's more of a generic abstract file that you take this protocol buffer format like file, like a metadata file. It tells you how to read the binary stuff, and then you can convert it into specific language that you want. So their tool will do that. And so I told it, hey, do a JSON version for me, and it did. Do I have that file somewhere? Probably. In that. Now you're not expected to do this, but this is how I got here. So this is a Java JSON version of like the concept of a tile object and how you read it in and how it's going to chop it up into geometry and line strings and polygons for you and organize it. Thank goodness I didn't have to type that file. But it's basically because they don't know what language you're going to use. They need to keep the description, the technical specification of how the data is stored in a separate type of file. Then you convert it to your language specific one, which is what I did. And then I just wrote a little node script. What does that mean when I say a node script? What's a JavaScript thing? So this is all JavaScript down here. And basically this just says, you have to import these libraries, which I did. The magic thing was figuring out this was called tile. So that's why I went into the JSON file and said, what did they actually call that? But this is the thing here, where we go get the protocol buffer format. It's a binary file. If we try to load it into an editor, get a bunch of strange characters on the screen and that. And this is the out file name, put it into 2.json kind of deal. And basically, hey, make a new buffer and then basically use that buffer, the in file, read it in with the object structure that was described in this JSON file. Where is it? Yeah, MVT.json file. And then I immediately just write it out. At this point, I have a JavaScript object, OBJ here. So I could use that in my JavaScript code, put it into the map and that kind of stuff. I just wrote it back out to disk so we could demystify what the heck is actually in this thing. So without further ado, let's go take a look. All right. And so the binary format is just so that you send a super small file over the wire, and then the browser gets busy unpacking it and that. And so this means like the leaflet client library does all this in the background for you. It knows about the proto file. It knows how to tear apart the protocol buffer format file, and it knows how to get it onto your map. But let's jump in here. JSON file. Okay, so it is JSON, curly brace, square brackets, right? But there's a concept of layers. There could be many layers. Like a map has many layers, right? And this is the name of the layer. And so this is not GeoJSON, right? And then there's some like an ID, like a primary key, and then there's a bunch of tag values, right? Maybe that's that and that sort of thing. And type 3 geometry, I bet you that type 3 probably means, hey, I'm a polygon. I have to look that up, but I bet you that's what that probably means. But here's the fun part is, yeah, those aren't real world coordinates at all. Okay, it's not even close. And so it is like a pixel space kind of system deal for drawing the polygon. And there should be a whole bunch of, there's more polygons in here in that, right? So the one thing is to understand that, okay, right, like this is not real world coordinates. These are just little pixel coordinates, and it's drawing in pixel space and that sort of thing. And so it very much is like a vector format of the tiled images of PNGs and JPEGs, and that it's just a vector format. And it's like, hey, draw from this pixel to that pixel. Now each tile, like I said, you could have like 16, 20 tiles coming to your map, and each of those tiles draws independently, and they all go to their own origin, upper left-hand corner, and start drawing downwards to the bottom right, using this sort of relative coordinate system, right? It's not an absolute coordinate system like the JSON and that. And so you can see all the different white space and this. So it's not like this in the binary file. There'd be no white space. It's all just shrink wrap. It's all binary. So it really shrinks the size of these files. Would it be worth it to actually, we probably won't see it here, but let's get out into Reveal in File Explorer, and maybe, that shouldn't be anything too sensitive here, in that, well, that's not bad. 26 kilobytes, 1 kilobyte, right? It's 26 times larger as JSON, right? So that's the whole idea. that JSON, GeoJSON, really big, right? Really big as text. So people like to wrap it up in this protocol buffer format. Really shrinks the size. Like in all honesty, this is the first check I did just now. I had no idea that it was like that much of a difference, right? 26 times compression. I don't know, 260%, no, around there. That's a lot, right? That really shrinks. And that's why people do it, right? That sort of thing. JSON's good, but it's big. Hey, let's send it as binary. It's still JSON. You can see how it comes back as JSON in the end in that. Because what you're doing is where's the bottleneck, right? And it, we talk a good game on bandwidth, but you have a bunch of people on cell phones really far away from towers, lots of people hitting the same tower, then you don't have that 5G bandwidth that they're talking about at all. And so that is a huge bottleneck in the networks, is you on your cell phone, pulling down a bunch of mapping data on top of a map. And it's a lot easier if we send something much smaller, because that is the slowest part of the system, is probably network. Once it gets to your device, typically your phone is like a supercharged like laptop. It's got almost as much muscle to parse the file, turn it back into JSON, and get it back up onto the screen for you. So we'll leave it there, but gives you a good idea of the big difference is GeoJSON. It's JSON, different format. Real world coordinates. This one, right, the Mapbox vector tile in protocol buffer format is technically binary. I just sent it back to text so we can actually see what's in there. But you can see the words geometry, and you can see the coordinates in that. Now the attributes are technically in here somewhere in this, but it could be down lower where they have the values stored in that. Yeah, the name, right? There would be a count in here somewhere as well. In that, so that the attributes are stored like in a totally different part of the file. But the idea is that when you send these vectors, because they're vectors, you can actually rotate the labels on a map rotate, and you can actually start stylizing the vectors as well. Like if you want to change the color and that kind of thing. Harder to do with the image because it's fixed. But we'll wrap there, and so that's all for now.